In my other videos, you might have heard me talk about PWM, or pulse width modulation. In today's video, I'm going to go into more detail on what PWM is, and how you can build a PWM circuit that can dim lights, control the speed of a motor, or change the amount of power going to pretty much anything you want. So let's start with a description of the waveforms. Here's what 10 volts DC looks like, and here's what 0 volts DC looks like. Now let's see what happens when you have 10 volts being switched on and off. Right now you can see that the waveform is 10 volts half the time and 0 volts half the time. Since it's 50-50, we say that the waveform has a 50% duty cycle. Since the 10 volts is only there half the time, what you end up with is an average voltage of 5 volts. Now let's change the duty cycle. Now the wave is only on for 10% of the time, so we say it has a 10% duty cycle. 10% of 10 volts is 1 volt, so we end up with an effective average of 1 volt. So you can see how by changing the pulse width, we change the average voltage seen by a circuit. We call this technique pulse width modulation.
Alright, that was a good start. Let's get another little recap of what PWM is, pulse width modulation. Okay, so like the guy in the video said, courtesy of Afrotech Mods, that's the YouTube channel. Here's a graph of voltage with respect to time. And so what we know about our computer is that our processor is capable on these digital, there's a reason they're called digital output pins, right? That's because they can either supply 5 volts or 0 volts. They can't do anything in between, right? Because of the digital nature of the processor. So a way to simulate outputting analog values is to use what's called pulse width modulation. And it's quite what it sounds like, and it's really a pretty easy concept to grasp. It's that by pulsing the width of the signal that we're sending out of our, say we have a pulse signal out of the digital output, just that by pulsing that, we can actually take an average of the pulses over time and cause a new average value to occur from that. So the example here is that if there's a 50% duty cycle, we call this the duty cycle of how much of the time of a full wavelength, you could think of it as, how much of that full time is the wave on for. Right? So 50% duty cycle means it's on for 50% of the time and off for 50% of the time. And a 20% duty cycle would be on for 20%, off for 80%, right? So in a 50% duty cycle, you get it's on for half the time, off for half the time, so you get exactly half of the voltage you would normally get. So if you have a 5 volt logic supply, you're going to get digital analog conversion, you're going to get 2.5 volts, right? So again, yeah, this is a way for us to convert digital to analog, because the processor isn't capable of doing that directly, but by pulsing this and taking the average of the pulses over time, you can achieve whatever value you'd like, anything in between 0 and what the logic level voltage is, in this case 5 volts. So let's go ahead and try it. The Arduino has the analog write function, which will make it super easy to access PWM capabilities from the Arduino. Alright, so I've brought us again to the Arduino reference page, and I just want to take a quick look because I want you guys to get used to using this reference page, because you're going to be on your own after this week, and you got to be able to look stuff up, new and old things, in order to continue on your journey of the Arduino experience. So analog write. Writes an analog value, PWM wave, so that's a square wave like we saw in the previous presentation there. Can be used to light an LED at varying brightnesses or drive a motor at various speeds. Ooh, right down our alley right now, right? After a call to analog write, the pin will generate a steady square wave of specified duty cycle until the next call to analog write. frequency of the PWM is approximately 490 hertz. Okay, blah blah blah. So this is good. So let's get some of the data that we need right now. Syntax, the pin, and the value is all we need to send to this analog write. And the pin is important because, as a matter of fact, you can't just use any pin for this case. The only pins you can use are, do you see in this diagram of the Arduino, do you see where the squigglies are? The squiggly lines here, that denotes which lines you can use this analog write to. These are the only pins that can use PWM. Okay, so if you do analog write for pin 4, it's not going to work. All right, make sure you're using one of the ones with the squigglies on it. Back to here. The parameters, the pin to write to, okay, we got that. And then the value. The value is the duty cycle, and it is between 0, which is always off, and 255, which is always on. So anywhere between, so what would 50% duty cycle be? It would be 127-ish, about 127 would be 50% duty cycle, because that's half of 255, right, approximately. So that is how we got the information for analog write. So let's go ahead and give this a try, right? Alright, so I'm going to go ahead and give this a shot. As you can see, it's a very simple program. We just have pin mode, so we just initialize our pin numbers. I'm going to go with 3. I haven't even changed my setup since the last demo with the changing the RGB light. So we've got pin 3 is the output, and then analog write, pin 3, and we're going to go ahead and run it at half the duty cycle and see what happens. That's it, guys. Let's give it a shot. Plug her in here, upload the program. And it has uploaded, compiled and uploaded, and we get a nice bright signal. And now I'm going to slowly bring this down. So I'm going to go ahead and delete 100 off there. So now we're down to 27 as our duty cycle. Remember, that's not a percentage. That's out of 255. So this is this is now down kind of around 10%, a little over 10% duty cycle, and we'll see how this light changes once that finishes. And bam. Okay, it's definitely a little bit dimmer, I would say, wouldn't you? That's good. Let's take off another number. Let's take off the 2, make it just a 7. So 7 over 255 is whatever percentage of a duty cycle this will be. So not much. And now it's getting really dim. So definitely appears to be working. We are artificially changing the voltage to this LED by changing the duty cycle of our pulse width modulated signal. Alright, so pretty cool stuff. Going from digital to analog like this, kind of in a tricky way. Alright, so I was going to type up for you guys a cool little program that cycles through the colors of the RGB LEDs. So it goes, red, orange, yellow, green, blue, the Roy Biv through the whole color spectrum. But I decided I'm going to leave that up to you guys to see if you can figure out that challenge. With some Googling and some artistry, you could probably figure out how to use red, green, and blue to mix and match them and sweep through the color spectrum. So, and also, you're going to need a for loop to do that probably. For loop is recommended. You're going to need to do something that's called nested for loops. So putting a for loop inside of a for loop. So I think I'm going to leave that up to you guys. See if you can figure that out. It's definitely one of the harder challenges you've had yet. But I think if you guys work together as a group, as table mates, maybe do a little bit of Googling and definitely ask a mentor for help too. But I think you guys can definitely get it, okay? So go ahead and give that a shot. If you haven't already wired up your LED, go ahead and do it. Rewind the videos if you need to see anything that was previously presented. But I think that's it.
You can do it! 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 You can